Okay, so the last part of section 4 is on synthetic division, which is a different type of division. I like it better, you might like it better than long division. You get the same answer whether you do synthetic division or long division, it's just a different approach to it. So with synthetic division, we care about the coefficients only. This number here is your box number. We're going to make a box. We're going to put that number in, but we always do the opposite sign of what's in the parenthesis. So we're going to put a -1 instead of a +1. Then we're going to take all these coefficients and put them in a line. So we got 1, 4, 1, and -6. You want to keep the signs with them if they have different signs. And then we're going to put a line. So we always drop down our first number. Always, always, always. That's going to be 1. Then we're going to multiply this bottom number times our box number. So 1 times -1 is -1. With synthetic division, we always add. Long division, you subtract. Synthetic division, you add. So we add the columns. 4 plus -1 is 3. Then we're going to repeat. 3 times my box number, -1, gives you -3. Then we add. 1 plus -3 is -2. Repeat. Multiply this bottom number times your box number. -2 times -1 is +2. And then add. -6 minus 2 is -4. This last number here is your remainder. These numbers here are your coefficients for your new polynomial. When you divide, you're always taking a whole degree out. So we started with a cubic function. Now you're going to have a square function. So these are the coefficients for your square. And we have 1x squared plus 3x minus 2. Right? In a quadratic, we have square single constant, just like we have here. Your remainder, we do the same way. Remainder over what you divided by. So we can say plus -4, or we can say minus 4 over what we divided by x plus 1. And again, if you want to write plus -4, it's the exact same thing as writing minus. Over here, B, this is my box number. We always do the opposite sign. So I'm going to write -4. I'm going to put my coefficients in. 3, where's my x squared coefficient? It's not there. We need a place filler. So we're going to put a 0 in for that. Just like with long division, with synthetic division, every place needs a spot. So if you're missing one, you put a 0 in as a place filler. And then I have my single, and then I have my constant. Oops, that should just be a 12. And we're going to put a line, and we're always adding. We always drop down the first number, multiply it to your box number. 3 times -4 is -12. Add your column. 0 plus -12 is -12. Multiply back. -12 times -4 is +48. Then we can add the column together. 48 plus -13 is 35. Then we can multiply that number times our box number, and we get 140, -140. And 12 plus -140 is -128. This is your remainder. These are your coefficients. So I can say 3x squared minus 12x plus 35 with a remainder of 128 over what you divided by x plus 4. And we know it's going to be x squared because we started with x cubed, and when you divide, you take away 1 power. So instead of a cubic function, now we have a quadratic function. So pause the video right now, try to do this next problem, and then resume the video and see if you got the answer right. Let's bring this down a little bit. So we make a box. Our box number is -4. Our coefficients are 2, 7, -6, -8. Drop down your first number, 2. Multiply that times your box number, -8. We're always adding. 7 plus -8 is -1. Multiply that to your box number, +4. Add -6 plus 4 is -2. Multiply that back to your box number, +8, and we get a remainder of 0. So our answer is 2x squared minus x minus 2. That's our answer. We have a remainder of 0, so we don't need to worry about putting our remainder in. Excellent. So remainder theorem is the last thing we're going to do. It says, if you divide a polynomial f of x, be a linear factor in the form of x minus a, the remainder will equal f of a. That is super complicated as a way to say whatever your answer is, that's the remainder. So one way they can give it to you is this. P of -1 for P of x equals 2x to the 4th plus 6x cubed minus 5x squared minus 60. They're telling you what your x is, -1. So we just plug it in. 2 times -1 to the 4th plus 6 times -1 cubed minus 5 times -1 squared minus 60. And that's going to give you 2 minus 6 minus 5 minus 60. And that's going to give you -69. This is your remainder. Why is this helpful? If I ask you a question like this next one, is x minus 4 a factor of this big polynomial p of x? We know if the remainder is 0, it is a factor. If the remainder is not 0, it's not a factor. So we can use remainder theorem to find out the remainder instantly to tell us whether or not it's a factor. The trick here, if I give you this, we use our box number. And our box number, we always change the sign. So we're going to plug in 4 into our polynomial. So I can say 3 times 4 to the 5th minus 8 times 4 to the 4th plus 2 times 4 squared minus 15 times 4. That is going to give us 996. That's not 0, so no, it's not a factor. So remainder theorem will tell us very quickly if our binomial is a factor or not. And that's the end of section 4.